Hey there, I'm Sam, and I'm a math tutor on Wyzant. Determine the cubic function that is obtained from the parent function. Okay, we need more details. Under a vertical stretch by a factor of 4, reflection across the x-axis, vertical translation 2 units down, and horizontal translation of 1 unit left. Oh, sorry about that. Okay, we got a lot going on, so let's kind of break it down a little bit more. First of all, I believe this was supposed to say y equals x to the third, because we need a cubic function that is obtained from a parent function. All right, so I wrote some values of y equals x cubed down here, and I choose pretty small values of x just because they're easier to graph and easier to conceptualize for me. So we start at the origin, 1, 1, -1, -1, 2, and then it skyrockets to 8, which I can't actually even fit on my axes, so sorry about that, but we can at least kind of draw a sketch, emphasis on sketch, and it looks something like that. Great. The first criterion is that we need to stretch by a factor of 4. So for me, I would sort of symbolize that or visualize that by pulling our graph vertically, obviously. What I just did probably wasn't a factor of 4, but I kind of want to leave this blue graph as the parent so we can keep comparing. So instead of getting, oh, I'm sorry about that. That's not correct. Let me fix that. And then also paste this. Great. So instead of getting just 0 here, do we expect to get something different? Well, the answer is kind of no, because that was sort of our anchoring point at the origin, so I believe it's still going to be 0. When x is 1, however, y now needs to be 4 times as tall because the graph is actually moving much faster now that it's stretched. So I believe we can multiply that by 4, by 4, by 4 to get a -4, and by 4 to get -32. Then we have a reflection across the x-axis, which to me means we're going to be taking our points and moving them as far up as they were to as far down as they will be now. So I believe this will give us kind of an inverted function. And however positive it was in the past, now it'll be that negative, which means we can flip the sign of all of our answers. So -32. I'll put the pluses just to emphasize this. Okay, great. And I'll delete that again. So far, we've taken care of the first two things. Now we need to think about a vertical translation of 2 units down. For me, that kind of means that we're just going to take our function and kind of beat it down a couple pegs and just say, whatever you used to be, we're going to take 2 away from you, which isn't quite the nicest way to think about it, but the way I visualize it. So for me, that means we'll be able to subtract 2, 2, subtract 2 makes it even more negative, a little less positive, and a little less positive. The last one is a horizontal translation of 1 unit left. This means that x kind of doesn't have to be as powerful as it used to be. And what I mean by that is instead of putting 0 in for x, we're now allowed to put in -1 for x and get the same answer out. Yes, this one's a little counterintuitive, so be careful. So if we subtract 1 from all the x's, we will get this. All right. Of course, we don't necessarily want to report a t-table as our answer. It's not the most efficient way of doing things. So instead, we want to convert this into a new cubic function. So I like to write it as y equals x cubed, and I'll use the caret notation to save time. But unfortunately, this wasn't good enough. So we had the vertical stretching factor of 4. So that means we actually put a coefficient of 4 in front, because remember, we multiplied by 4 every single time. Then we also had a reflection across the x-axis, which means we'll take whatever our answer is and we'll just make it negative. Remember, we symbolized that in our t-table by just flipping the sign of every single term. We're not quite done. We also have a vertical translation of 2 units down. It's knocking it down a couple pegs, which just means we take 2 off our solution. And the last one I think is the most difficult, but you got this. And I'm speaking to myself and you out there, that it's not just x anymore, but instead we have an x plus 1. Remember, our x was kind of aided by something, which meant x could be a little bit worse or a little bit lower than it used to be before and still result in the same y value. So we actually kind of flip the sign there and do an x is plus 1. All right. And sorry, the parent graph was kind of a mess, but I think the function actually looks good, and I hope that helped.